Okay, so this next question is asking us, how can we tell if a parabola opens up or down, and if the vertex is a min or a max, just by looking at the equation? Just by looking at the equation. Well, can we do it by looking at the equation? Well, maybe not. So then we would have to graph it. But gosh, this would take a pain in the butt to graph this, because check it out. I would have to click on my graphing utility. I know you don't have one, but you have to get out your graphing calculator, and from your graphing calculator start typing in this function to see, right here, this function to see, and then graph it and wait for it to graph it, and next thing you know, the hour's gone, right? Okay, so there's got to be an easier way to do this. So let's take a look. I got right here, I'm at Desmos right now, and what you can see here is I got a quadratic equation here. I got an A, B, and C, and those A's and B's and C's are right here. I can manipulate those. And let's just see if maybe one of these letters will tell us something about the function that will tell us if it's opening up or down. So let's just kind of start by taking a look at the C. Let's see what the C does right here. What does the C right here do? Right there. And so we're going to move this C up and down, and we're changing it. See how I'm changing the C right here. And it looks like when I change the C, it doesn't change if it opens up or down, right? This quadratic equation is always opened up still. It just shifts it up and down. So it doesn't look like the C tells us much about whether it opens up or down. So let's move on to this B. Let's see what the B does. When I do this B, it does what I have no idea what it's doing. It's like rotating it over this point in the middle, something like that. See, it kind of goes up and down, but it definitely doesn't make it go open up or down. So it's always still open up with this. So let's see if this A tells us something. Okay, moving this A, it makes it nice and skinny. Look how skinny it's getting. Okay, let's see. We'll go back this way. The A. Oh, wait a second. Did you see that? It like went upside down. Now it's open downward, and now it's open up. So it looks like changing this A will make it go up and down, and it looks like, let's see, when does it happen? I'm at positive, it's nice and skinny, and now I get to 0, and it's like a straight line, and then I go to negatives, and it's upside down. So it looks like when A is a negative number, it's open downward, and when A is a positive number, it's open upward. And so that is method 2. Method 2 is get the equation in quadratic form, and if this A is positive, the parabola opens up. So positive is up, okay? And the vertex is a min, okay? Maybe put that in there, okay? The vertex is a min. And then if it is negative, the parabola opens down, and the vertex is a max, okay? So let's use this information to answer this question right here is, does the parabola open up or down, and is the vertex a max or a min? Okay, well, remember, it's all about the A. And if we go back to this graph, notice, I want you to notice something, because if you don't notice this, you're going to be in trouble. The A is connected to the x squared term, okay? So you got to find the x squared. This might not be in order. This might be over here, or it might be in the middle someplace. You got to find the x squared term, and then you'll know what the A is. So let's go back. Now knowing that, let's take a look at this, and let's identify what is the A in here. We got to find the x squared term in this function right here. So let's find it. Here's our x squared term. So in this situation, our A is negative, right? And since our A is negative, it's actually negative 5, right? Let's go back up here and look. In this situation, if A is negative, the parabola opens down. So we know this opens down. And because it opens down like this, the vertex right there is a max. So we know the vertex is a max. Vertex is a max, okay? So that's looking at this one. This one's in standard form. It's kind of easy to see that. We just find the A. We know it's opening down, thus making the vertex a max. Check, check. That's nice. Now what about this situation right here? Check out this one. This one is not in standard form. And so before we can answer the question is, does the parabola open up or down, and is the vertex a min or a max, we got to get it in standard form. And so we're going to use the box method to do that. Let me get this sucker in standard form. Let's do that nice and quick. Just like I did on the other page, I'm going to put the 4x and the 1 here. You could also put it on the side if you wanted to. It does not matter. That's the beauty of the box method. There's other beauties too in it. So we got that there, and now what we're going to do is we're going to figure out what the equation is. But check this out, watch this. I got x times 4x, which is 4x squared. That's the only term I care about, right? Just the x squared. None of these other terms are going to be x squared. So check out, this one's 16x, this one is just x, and this is 4. Who cares about these? Our question is, does it open up or down, and is the vertex a min or a max? And that's all determined by this term, which has a positive coefficient. That's what it's called. So let's just, from that 4x, identify, does it open up or down? Well, the a right here is positive. So therefore, it opens up, and the vertex, because it opens up, the vertex is a min. There's your vertex. And so that's how you can determine if you got a parabola that opens up or down and what the vertex is. Just figure out what the a is.